Hi Techstars, you're welcome to TPM Simplified, where we make technical product management easy to understand even if you're not technical. My name is Eniola. I am a technical product manager who is passionate about breaking down complex product concepts into bit-sized, relatable content. Whether you're switching careers, just starting out in tech, or you're a non-technical stakeholder who wants to understand the lingo, this channel is for you. We started off a few weeks ago on demystifying technical terms. And today we'll be continuing on these terms. The terms we'll be looking at today are SDK, known as the Software Development Kit. We'll be looking at tech stack. We'll also be looking at scalability, what scalability means, in simple terms. We'll also be looking at what architecture means in tech. We'll also be looking at code freeze. Yeah, these are the terms we'll be demystifying in today's video. I would encourage you that you sit back, you relax, and you come along as we demystify these terms in this lesson. Starting off with the software development kit. The software development kit is often called the SDK, and it's like a shortcut tool set for developers. And so basically it helps them build app faster. It helps them add features like maps or payments, and it connects to services like Google, Stripe, payment platforms. And the major use of SDK is helping developers use fewer line of codes and also reducing error. As usual, I would simplify using a simple analogy. So you think of an SDK like this. The SDK is like a tool used in building a house. Okay, so tools like hammer and nails to build a window is an SDK. And let's imagine that the application you are building is definitely the house, right? The hosting platform is the land where the house sits. The deployment is the truck that takes your house pieces to the land, right? And the code editor, that is the Visual Code Studio, is like the workspace. And so the SDK helps to build a part of the house, like a door or a window, even though you still need a place to write the code, a server to run the code, and a tool to send your code there, right? Okay, another example I would love to share is you trying to integrate a service provider to your platform. For example, you're trying to work on an SMS platform, right? And you're trying to integrate a service provider like Telnext, right? The Telnext SDK would help developers write codes to send messages, manage numbers. But you still need a web platform to host the app, a back-end system to run the business logic, a deployment process to push the app online, right? So an SDK is a combination of libraries, APIs, documentation, tools, examples, and setup files for developers to make their work easier, to make their work faster, and to make their works have reduced error. So now we are moving to the next term, and that is tech stack. What is a tech stack? A tech stack is a set of tools or programming languages used to build or run a software application. So think of a tech stack like a layered cake. Each layered cake serves a different purpose, right? And together they make the whole thing work. Let's still use the analogy of building a house to explain the tech stack. The foundation of the house is likened to be the database, right? So this is where like the data is stored. The walls and the rooms at the back end, that is the logic, right? The paint, the furnitures at the front end. So basically the back end is, what is happening behind the scene, the logic, what the developers are, the language the developers are speaking to the computer, and the computer is understanding and interpreting. While the front end is what the users see, the paint, the furniture, the interior is what you can see, and so that's the front end. While the builders or the bricklayers laying the blocks and digging the foundations are like the back end, right? And the tools and the materials that is used to build everything is the tech stack, right? So each that is the foundation, the walls and the rooms, the paint and the furnitures, all of these materials used to build all of these things is known as the tech stack, right? So the tech stack is made up of layers. Like, remember I said that a tech stack is a set of tools or programming languages that is used to run or build a software, right? And so we have different layers that are used to build a software. We have the front end, we have the back end, we have the database, we have the server, and we have the version control. We also have APIs, and of course we have SDKs, right? These are layers, things that sums up to build a software. So things that we put together to make sure a software is live. Majorly, when I say live, that means it's functional, right? So we have like these layers are all called the tech stack, right? Yeah. So the front end is what the user sees and interacts with, and we have examples of front end applications. We have the HTML, we have the CSS, we have the JavaScript, we have React. All of these are examples of the front end. Then we have another layer that makes up the tech stack. We have the back end, which is a layer, and the back end is the logic, is the processing, is the business rules, right? The major thing that makes the building stand. Yeah, without the back end there will not be front end. It's like saying without the bricks there will be no building. Yeah. And examples of the back end is the nodes. We have the Node.js, we have Python, we have Java, we have PHP, we have Laravel. These are examples of the back end. Yeah. So another layer used that makes up the tech stack is the database. This stores data like the users, it stores messages, it stores orders. That's the database where data are stored or informations are stored. An example of the database, we have the MySQL, we have the MongoDB, we have the PostgreSQL, we have Firebase. These are all examples of database. Another layer that makes up the tech stack is the server or the hosting. Some people call it server, some people call it hosting. In my previous video, I mentioned that the stack and the server is where the app runs, and where informations are accessed online, right? And examples of server or the hosting is the AWS. We have the Vercel, we have Netlify. They are all examples of the server or the hosting. Another thing that makes up the tech stack is the version control, and this actually tracks changes in the code, right? It's like the web based platform. In my previous video, I made an explanation about this. I would encourage that you see the previous video to really understand it. An example of the version control is the Git, the GitHub, the GitLab, the Bitbucket. They are all examples of version control. Last but not the least, that makes up a tech stack is the APIs and the SDKs. APIs, they help the application talk to other apps, right? I explained this in a previous video too, and so I would encourage that you do see previous video to understand what an API is. And then previously I'd explained what an SDK is, right? A quick recap: an SDK is like a tool set for developers. Yeah, so different providers have their SDK, right? This would help the developer, build the application faster, add features, and connect with services, right? Yeah, so I think we are done with the tech stack. All right. So we are moving forward to the next term, right? The next term, and we are looking at latency. Latency is just simply how long it takes for your action to be notified or for the response to come back. Yeah, latency is how long it takes for your actions to be noticed and for response to come back, right? So when you click a button, for example, you click the send button on an app, the latency is how long it takes for the software to notice your action and the time it takes for it to respond. That's latency, right? So if you send a text message and it takes 2 seconds for the message to arrive, so that's a 2-second wait. That 2-second wait is the latency, right? So the time it takes for your action to be noticed and for a response to come back is the latency, right? And so if the latency is lower, it means that the response is faster. Yes or yes. So if on this, so let's say for example we have 2 different applications, and on an application, when I click send button, it takes 5 seconds for me to get the feedback, and on the second application, when I click send button, it takes 2 seconds. We can say that on the first application we have higher latency, while on the second application we have lower latency. Yeah, so lower latency equals to faster response and equals to better user experience, while higher latency equals to slow response and it equals to frustrating the users, right? So the latency is the tiny wait time between asking and getting an answer from an app or a computer. Yeah, so I think that explains latency. Moving forward to the next term, we'll be looking at scalability. What does it mean for an application to be scalable? Yeah, in my own words, I would say that scalability means how well the system can grow and handle more users without breaking down or without slowing down, right? So imagine that you have a juice stand, for example, or an ice cream stand that can serve 10 people easily. So when 10 people come to the ice cream stand, they would get a cup of ice cream, and suddenly we have 100 people come. Can the ice cream stand still serve them quickly? If yes, that means the ice cream stand is scalable. But if no, it means that the ice cream stand is not scalable. Yeah. So in tech, if the app works well with 10 users, and it also works well when we have 10,000 users, yeah, at the same time, it means that the app is scalable. Yeah, so when you're building an app with the developer, you tell the developer that, oh, one of our major goal is to ensure that this app is scalable, meaning that it can accommodate as many people as we want, right, per time, or as many people that accesses the website per time, right? So scalability is really important because it helps to keep the app or website fast and reliable as more people use it. You don't want a situation whereby because of the large number of people using the website, there's a breakdown or we are having slowdown. Like, sometimes when you access some websites and there's a high influx of people, or there's an influx of people using that website at that time, you'll experience a glitch, like slow down, you know you you experience slower latency. Higher latency rather. You experience higher latency. That means the app is not scalable. Yeah. So we need scalability so that to ensure that our app or website is fast and reliable as more people use it. And also we need scalability to avoid crashes or slowdowns during big traffic spikes. Yeah, majorly. So in summary, scalability is how well your app or system can grow and still work great for lots more users. Yeah. Moving forward to the next theme, we'll be looking at architecture in tech. What does architecture in tech means? Yeah, so architecture, is like the overall structure and design, right? And so in tech is simply the overall structure and design of how a software system is built. Okay. We can also say that is the blueprint of how everything works together. So imagine this: you're building a house. Before construction, an architect draws a plan that shows where the room goes, where the doors and the windows are, how the plumbing and the wiring will run. That's architecture of the house. In software, architecture is the big picture plan of how the front end would look like, right? What the users will see. Yeah, so it's like a big picture plan of how the front end talks to the back end. Yeah, so meaning that, okay, when a user clicks the send button, how the front end relates with the back end for it to give a result, right? It's also like a big picture plan of how data works or how data flows, what services are connected, how all the parts of the system communicate and work together. So architecture is like, the big plan of how the front end relates with the back end, how data would flow, how the services are connected, and how the parts of the system communicate and work together. We have common components of the software architecture. We have the front end, we have the back end, we have the database, we have the APIs, we have the servers. Yeah, these are all components of the software architecture, right? And so let's say in a simple messaging app, I love messaging apps a lot. So in a simple messaging app, the architecture decides where to store the messages, how the messages are sent and received, how fast the app should respond, what happens if the internet is slow or it fails, what response should the user will get, at the front end. So that's majorly the architecture. In summary, we can say that architecture is the master plan of how software parts are organized, how they work together to make the whole system function smoothly. Okay, we go to the last term we'll be looking at in this video, that is code freeze. What is code freeze in tech? Code freeze means developers stop writing or changing code for a while. So most times code freeze occurs when when a big release is in view, when an update is in view, or when a launch is in view. So it's like saying no more changes, let's test and fix what we already have, right? So imagine you're baking a cake, and once the cake is in the oven, you stop adding ingredients. Yeah, that moment is a freeze, is a code freeze. You are done mixing. Now it's time to bake and finish. Yeah. So why do teams use code freeze? To prevent new bugs before it release. I mean, the more you work on an application, the more new things, there are issues, or there's a breakage somewhere, or there are bugs, but when there's a code freeze, it means that no one is working on the project at the moment, and so we're just working with what we already have, right? And teams use code freeze to focus on testing and fixing the existing code. We're not adding a new code, we're only focusing on testing and fixing this code. We also we also use code freeze to ensure stability of the system before launch. All right, so when does code freeze happen? Code freeze often happen before a big product launch, like I said, yeah, or before a very high traffic event. So okay, there's supposed to be like a Black Friday sale on the website, and so the product manager is saying that there will be a code freeze from Wednesday through to Friday, because we don't want a glitch, right? Because we don't want a breakage. Yeah, so there'll be code freeze. Yeah, another reason why code freeze happens is during the end of a sprint testing. So a sprint as we run a sprint. Sprints are often 2 weeks. Yeah, so a sprint we run a sprint, and then we are done. We want to test what we've worked on, so that is when we have a code freeze. And of course, we introduce code freeze before deployment. So when you're about moving from when you're working on to, when you're about pushing to production or to live, we most times introduce code freeze. Yeah. So code freeze is like a pause on making code changes, so the team can test, can fix bugs, can get ready for launch without risking last minute issues, right? Yeah, so I think that is a major explanation about code freeze. So far, we have looked at code freeze, we have looked at software architecture, we have looked at scalability, we have looked at latency, we have looked at tech stack, we have looked at SDK, and I hope that you have a better understanding now about each of these terms. In our coming video, we'll be looking at other terms, and also the process, or how product management works, what it entails, what you should do, how you should go about it, and I would encourage that you subscribe to this YouTube channel to ensure that you are up to date with information as regards technical product management. Thank you, and bye for now.